Here, I'm going to put this thing back on speaker view. So yeah, I mean, if you're up for it, let's go into Q&A session then.
Yes.
Yeah. And again, John, thank you so much. I know Zoom, the folks in the audience.
I'm sorry. I ended up in a quarrel with some people at the company who said they just, so I finally got to negotiate it down a non-disclaimer disclaimer.
That's okay. You know, what I wanted to let the audience know was I was on the phone with you actually, while Bob was wrapping up the Q&A, and it forced you to do like a last minute upgrade on Zoom. So
yes, unfortunately.
Yeah, so that's kind of why we ran into these.
It's okay. No, it's a great. I work for a great company. They're very supportive of this, but not everybody in the company is completely on board with this, and I understand that.
Yeah. Well, so let me go to Morgan first for questions. Morgan?
Yes, Morgan.
Yeah. Okay. Can you hear me? Okay. Sorry.
Yeah. Yeah.
Okay. So first question. Also, thanks for this presentation. This has always been a very interesting subject. This Martian business has been really interesting because it's kind of hard data.
Yes, it is. It's all NASA data. It's not some farmer out in his cornfield taking a picture of lights in the sky.
Where does the dates, the 180 million years ago, where does that date come from?
Oh, those are radiometrically dated rocks. Any rock you can use what's called potassium argon method, etc. Various other methods there are certain elements in the universe that decay very slowly that are in the rocks, and you can find how much you can estimate how much was formed initially in the rocks and then see its daughter products and estimate the age from those ratios. So they come up with 180 million years ago is when these rocks were molten lava. Now, this has caused a lot of trouble in the Mars community because almost all of the Mars meteorites are about that same age. They only have one very ancient meteorite at about 4.2 billion years old. That's ALH 8401. That was the Mars life rock. And now they've been waiting to get more meteorites of intermediate age, but it's been very hard. Mars is kind of bimodal. It's either very old or very young.
But all of them are going to come from the same. So even like I guess I don't know this one that's in Antarctica, but whatever meteorites we pick up that are from Mars are 180 million years old. And then also,
well, most of them are. Some of them are about 1 billion years old. So that's helpful.
Okay.
By the way, they also show the oldest meteorite from Mars doesn't show that it absorbed xenon-129, meaning this xenon-129 abundance was something that happened late in Mars history, not early.
Yeah. Oh, wait, late. What do you mean, like as in greater than 180 million years ago? What do you mean by late by that? For the xenon?
Oh, yeah, about 180 million years ago. I say that because that's when some of the rocks that have been exposed to intense neutron bombardment, like from a nuclear explosion, they're 180 million years old.
That's it. So you have, I mean, does this come from multiple sources then in the sense of?
Oh, yes. Please, I encourage you guys.
So everything's pointing at the 180.
Yeah, you can, there's called, one of them is called the Mars age paradox. And the fact is, we look at Mars and half of it looks like it's very old.
Yeah.
And half of it looks like it's very young. And then, so we seem to be getting meteorites almost exclusively from the young part of Mars. It's very odd.
Well, or go ahead, Tim. Sorry to cut you off.
Oh, sorry. Yeah, actually, I had a question, but go for it.
Okay. Well, I just wanted one quick follow up. In terms of these rapid processes, which could create these excesses, you had mentioned a solar source. So it's either nuclear or solar. And so what I wanted to ask is, I've always heard something about these like micronovas or something like this, and that on the surface of the moon, you see almost like a glass structure, which could in principle come from these micronova events. Is there any correlation with that? That what happened on Mars?
Yeah,
I
must confess, I'm certainly aware that they have evidence from the lunar rocks brought back by Apollo of some kind of solar flare-up at some point, like a micronova. But I haven't heard of anything resembling the neutron creating anything like the neutron bombardment that they see in the Mars rocks. So that's all I know about it. I have not, and it's funny, you don't see much discussion of that interesting event.
Yeah.
Well,
okay. So, yeah. Thank you.
I think the Romulans and the Klingons had a dispute near the moon. So I think that's what that is all about.
If it's okay, let me jump in. I usually I don't have questions, but I do have a quick one. So on the Mars 2020 Perseverance mission, right? The Perseverance rover, the new one that just landed, it has something. Yeah, it has something called RIMFAX on it, which is, let me see, radar imager for Mars subsurface experiment. John,
yes.
do you have any thoughts about whether they might detect like some kind of artificial structures with that, or?
Well, if they have kept those cards close to the chest. We noticed that the Mars rovers and landers all tended to avoid Cydonia Mensa and Galaxis Chaos. They landed as far away from there as possible. They still seem to find some odd things on the surface, suggesting a past civilization. But I've just concentrated on the orbiting, the pictures taken from the orbiters. Yeah, there's another probe they sent to Mars. I think it was Intrepid or something. They launched it from Edwards Air Force Base. Now, to somebody who's worked in the space business with the Defense Department for a long time, what that means is it had a classified payload. So they sent a classified payload to Mars. We don't know what was in it, but I think they were testing the soil for various telltale isotopes to see if my hypothesis was correct. And as near as I can tell, we're still going to Mars. So I think they've absorbed that data and we're going to Mars.
Yeah. Well,
why are we going to Mars exactly, says the public to the government? For science. No, it's about survival.
Well, John, let me thank you. Let me go to Bob Greenyer next. Sir?
Okay, yes, Bob. Another plasma guy.
Oh, and Bob, you're muted. There we go.
Yes, Bob.
Oh,
how can we help you?
I think Bob. No, he's still there.
Yeah,
he's still muted. Asked to unmute.
He's talking with his hands. I'm using sign language.
There, allow participants to unmute themselves.
Thank you.
My apologies. I don't know how that got checked. Okay.
John, thanks for an excellent presentation. And it's nice.
Thank you very much.
It's very nice to see some updated images of those faces on Mars. I wasn't aware of those.
Yeah. They keep telling you, oh, they showed nothing. Move along here, folks. There's nothing here to see. And if you look at the actual pictures, it confirms everything.
Yeah. So I'm sure everyone who's thought about this long enough will conclude that there's a probability of one of there being life on other planets in some place in the rest of the universe.
The only question is, how far would you have to go to find it? And apparently we didn't even have to.
I think the more important question is, how much time would it take to get there?
Yeah.
Well, and the panspermia hypothesis, right? I mean, the planet seeding and all that.
Without going off on a tangent,
that's a tangent.
DNA is able to transmit. Can it transmit torsion waves through relic neutrinos? If it can, then if it can receive then you don't need to go anywhere to have DNA transmitted. And so you can look at the work of Luc
Life
Montagnier.
will find a way.
Well, and if you look at the work of Luc Montagnier, he was able to record the electromagnetic emissions from the AIDS virus, send that to a lab elsewhere, and use a PCR reactor to reconstruct the virus using the electromagnetic information. So you don't need to send the DNA, you just send the wave function. Okay, so that wasn't my question, but it's an interesting aside. So I had the pleasure of hosting, I think he's a Bulgarian, Stoyan Sarg, in 2014. He wrote this Basic Structures of Matter, Supergravitational Unified Theory. He also wrote a field propulsion book and is one of the few people to have replicated John Hutchison, at least inadvertently. Anyway, I think it was in about 2016, he sent out an impassioned warning because he's an atmospheric scientist. That was his expertise, and he's taught for many years as a professor at University of Toronto. And he calculated that if you had two nuclear explosions simultaneously anywhere on Earth, that would produce a self-sustaining vortex pair, and that would strip the atmosphere within a number of hours, which would boil off the oceans, and you'd basically be able to kill a planet with two simultaneous explosions near instantaneously.
What you're telling me is a global nuclear war would be a bad idea.
Just two nuclear weapons going off at the same time of sufficient size would set up this self-sustaining vortex. He'd done the maths. And it's very interesting because he then in this talk with a colleague, he said, I believe this is what happened to Mars and how it died.
Oh, interesting. Well,
and so this is the first time that I've heard anyone else talking about nuclear events on Mars. And it's also very important because you identified two locations. Now, I don't know whether he read your work and did the maths and realized that this is exactly what would happen. But it may have just been two warring parties, and they launched a bomb at each other, and they didn't realize they were going to strip the planet of the atmosphere.
The civilization looks like it was roughly Bronze Age, Old Kingdom Egypt, Mayan, Aztec. But we don't know. We don't know what this level of technology was. We have to have boots on the ground. Any archaeologist will tell you, by the way, JPL could send one of its rovers and drive around Cydonia Mensa for a year and not see anything. You got to dig.
Well, I can tell you from my own experience, if you don't look, you don't find, and you have to look in the right way, and you have to look in different ways.
And by the way, my experience also is that skeptics hardly ever discover anything.
They already know it doesn't exist, so why should they bother wasting their time?
Looking for something,
Yeah, so thank you. This is really interesting, and I think I'm going to reach out to Stoyan and point him to your presentation here. I think it's a meshing of it's a very serious message.
It is
of this little blue bubble we live in, and how fragile it is. So thank you for alerting me to your understanding.
Avoid nuclear wars.
Just avoid two bombs going off at the same time.
Just involve nuclear bombs going off at the same time.
And Bob, I am working on setting up an interview with Stoyan, so I'm going to email you and pester you for questions I should ask him. So
fantastic, great.
Yeah. Well, thank you. Here, let me go to Michael Boyd next, sir.
Yes, Michael.
Okay, can you hear me okay?
Sure can.
Loud
and clear.
So I have a question about some features that I observed in crustal features, what appear to be magnetic domains. I have a request, Tim. I'd like to share screen, but not on this, but my other computer that's showing my acoustic levitator.
Yeah, go for it. Yeah,
okay.
Thank you, by the way, Michael. I have received my acoustic levitator that you got me. I'm going to start some experiments soon.
All right.
Cool.
Do some levitation.
Let's see
I
here.
naturally
If I
like
got
to do
this.
it with electromagnetic
Okay.
fields, but you can do it with sound waves. That's great.
Okay, can you see that? Oh, wait, it hasn't showed up yet. Let's see. Should be showing up.
You can levitate
There it
water with
goes.
those, right? Ah, there we go.
Oh, okay.
Okay.
That's very interesting. Yes.
Okay, so hold
Yeah.
on. I gotta reduce that down. And so now I'm showing you this, and you can all see that they're in the southern hemisphere. There's these interesting magnetic domains showing up. Now, what I want to do is I'm going to unshare, and then I'm going to share a different screen. Where is it? This one. Now, do you see that?
Yeah.
So what we're looking at here is an image made with a thing called a magnetic force microscope. And what it's looking at is a written track on the surface of a magnetic recording disc, like in your hard drive. Okay, and this is what popped up in my mind. And now, so what I want to do is I'm going to show you that again. I'm going to change. Now, do you see? I have that. Can
Yes.
you see how that's like? So now
Mars is a very interesting place.
the Earth has a dynamo type magnetic. It's kind of like a motor, and that's what produces our magnetic field, which is a shield, a magnetic shield of the Earth.
Yes.
So like during, if the Earth got hit, was in direct line of sight of a solar flare, for example, the atmosphere would prevent us from getting, exposed to X-rays, essentially. And we're still subject to coronal mass ejections, which are basically proton flux.
Yes.
Now, the Mars, for example, if its atmosphere was CO2, like CO2 isn't a lot of our atmosphere, it would definitely, for one, it wouldn't shield the planet like ours does from the X-rays. And so the other thing I'm thinking is it possible that it was a coronal mass ejection event?
Could have been.
Something natural caused this.
I have not looked in that.
That's one hypothesis. And then
I
the
would
other
naturally,
hypothesis
by the
is
way,
that it was interplanetary nuclear war. And what we see today as Mars is a result of that interplanetary nuclear war. And what we call the asteroid belt is the other side.
The side that lost.
The side that lost. So, taking what I would call the non-binary view versus the binary view.
Well, because in my university astronomy class, they teach that one half of Mars is covered with craters, and then the other half is like where Cydonia and whatnot lies. And then I've often wondered, is the asteroid belt, because it doesn't fit into these like modeling scenarios of how solar systems created, could it have been a bigger solid fourth planet that Mars was a super moon to and then many planets that are also in the asteroid belt would have been also these moons of this possible larger planet? Is that a possibility?
Well, so my concern is the isotope analysis that you're talking about is if you could produce that isotope naturally without nuclear war. For example, you mentioned a supernova event.
Well,
correct?
Both thorium and radioactive potassium can be produced
So in a
by any,
supernova, why? But isn't essentially what's going on in a coronal mass ejection the same process?
well, the solar, you find almost no thorium being ejected from the sun or potassium. It's all mostly hydrogen.
I think,
that's
yeah,
what
I think, I mean, John, if I could jump in, I think what Michael is asking is if something like CMEs might be causing this as a reaction. But Michael, I guess something to consider would be, all planets are exposed to these, right? And so we would probably see all of this on the moon if it was caused by events in the sun.
Right. This is something unique signature on Mars in its crust of it's like it used to have a core, and the core is no longer where it's supposed to be.
Well, Mars,
remember,
Mars is 1/8 the mass of the Earth. So if it had a hot core, it lost its radioactive decay heat much earlier than Earth did. But
well, it's a unique feature.
Very adaptable. I think that Mars probably was a good place to live in any case.
Right. So I'm just curious.
I don't know.
If you would look into this anomaly in the southern hemisphere with these magnetic domains showing up in the crust.
Well, it looks like there was this, you have a remnant of a south magnetic pole on Mars from this earlier period of intense magnetic field. But yeah, I haven't looked at the magnetic data simply because I didn't think it would, like I said, I originally thought this was due to underground natural nuclear reactors. So I basically followed the big explosion hypothesis on Mars. Or
so I'm gonna
Mars surface.
Just for the FYI, thanks for your answer. I appreciate it.
Oh,
but I'm gonna put in the chat a link to the Wikipedia site where the link to that image, so you can have the source of it. Okay.
Sure.
Okay. Thank you again. I appreciate your answer.
Well,
Michael, thank you. Let me move along to Charles. Charles, go for it, sir.
So in a few years, Elon Musk wants to send starships to Mars. I was wondering what dangers will the first humans have, and what we should do to terraform Mars before we go.
I wrote a book called Death on Mars, and I discussed this. I think the dangers for the first Mars crew
sir, I'm sorry to interrupt, but for somebody that has such power, you're so negative in the future idea of humanity reaching out there. I'm sorry, please let me speak. Like every person, like somebody tells you like futuristic, you go history.
Okay,
like,
Lulu, I'm sorry, I have to mute you. Okay, I'm sorry. Can you go ahead, John?
I'm sorry. Where were we? We were
sorry. You were talking about you wrote a book.
The dangers, the dangers to the first people who land on Mars, if they're landing at Cydonia Mensa, where I believe they should, and looking around and digging into the rubble to find some kind of artifacts. They'll experience what a lot of people experience when they go to the site of a massacre. That's my belief. And the psychological toll that takes is tremendous. This is why I recommended in my book that we establish basically a base camp on Phobos first to kind of give psychological support to whatever ground team is on the ground, that they can look up and see Phobos orbiting overhead. And it's kind of their link to Earth, link to humanity. The first people who excavated Pompeii, where there was a volcano that swallowed up an entire city of, there was Mount Vesuvius. One of the last comments by, I think it was Louis Stevenson was City of the Dead, City of the Dead. And he wrote that shortly before he died. Apparently the stress of finding all of these dead bodies and ruined architecture it took its toll on him. He was just an English Victorian gentleman. He just wasn't used to this sort of thing. And so I recommended that we send some pretty, I recommended we spend combat veterans, who are in the special forces, would be the first part of the special landing team, people who have demonstrated great psychological toughness.
Okay, interesting. Thank you.
Awesome.
It'll be tough on the entire human race to discover that when this, if I'm correct and this is all confirmed, it'll be very tough on the human race as a whole. There'll be a lot of sleepless nights on Earth.
Okay.
Awesome. Okay. Well, let me go to Jared next. Jared, go for it.
Yes,
Sir.
Jared.
Hey, John. Excellent talk. Really loved it.
Thank you.
I hope you'll stick around. My talk is going to have some plasma physics stuff and maybe some LA&L relationships.
Oh, great. Some plasma physics, of course.
Yeah, I think you could provide some excellent insights on, if you would. My question, though, is in the maps where you were showing the radioactive locations,
yes,
it looked like there was an area or two on those where there was the opposite. There was concentrations, negative concentrations, right? It was totally lacking in any of these isotopes. I was wondering if you could provide any explanations on that.
The global surveys of the abundance of radioactive potassium and thorium on Mars show that the surface is very much depleted. I mean, the surface has a hyperabundance of thorium and radioactive potassium relative to the Mars meteorites, which are supposedly parts of Mars, presumably from a few meters down in the surface, where they can be ejected into space by a larger impact. So it's all very peculiar. It's very, I guess I don't have enough information right now to really comment on what that could mean. It looks like there were just two sites of tremendous activity on Mars, followed by an antipodal deposit for both. And that's about all I can figure out from those pictures. But Jared, you've raised a very good question. I don't know how to answer it, unfortunately.
So not like they were mining all of the materials from that location, only to then later explode those materials.
Yeah, there's no evidence for any cratering or excavation or anything at either of those sites. It's just smooth as, it's part of the very smoothest and uncratered part of Mars. So, like by the way, there's a strange black triangle hovering over your shoulder. Yes, thank you.
That's his,
by the way,
his unique Zoom background.
As anyone who's followed in depth the UFO question, parts of it read like a science fiction horror movie now, with animal mutilations and abductions and occasional military clashes. This is what we found on Mars is quite consistent with that, what we're experiencing in the UFO field, I believe. That the universe is a mixture of good and bad. Don't expect it to all be warm and cuddly. Some of it is warm and cuddly, but some of it also can be quite unpleasant.
Yeah.
That's what I think.
Well, thank you, Jared. Let me go to Bruce Cornett next.
Yes, Bruce.
Oh, Bruce, your mic is
We're
really
not hearing
faint.
you very well, Bruce. Turn up your volume.
Can you turn your volume? Yeah.
way low. Can you hear me now?
Much better.
Yeah, I can
Much
hear
better.
you now. Very good, Bruce.
Okay. My background in college was studying the Triassic-Jurassic rocks of the Newark supergroup, age dating them by palynology. And I collected thousands of samples. I processed thousands of samples in the chemical lab to extract the pollen. But what I discovered during that period was that there was a mass extinction at the Triassic-Jurassic boundary that hadn't been known before. And why I'm talking about this is your 180 year date for basalt on Mars. Well, the basalts of the camp, the Central Atlantic magmatic province, that with the opening up of the Atlantic Ocean that occurred at that time, the age dates for there run from approximately 205 to 180 million years ago.
Was this the Great Permian? Was this the Great Permian extinction?
No, it's the Great End Triassic extinction.
Oh, okay. Well, yeah, we've lost track of our mass extinction events.
Right,
so
or at
many.
least 6 of them in the history. And
Earth is rather accident prone itself, apparently.
Well, what is important for your consideration is that the age date has been narrowed down by dozens and dozens of researchers who've analyzed the basalts, and they have concluded that the event happened at 201 million years ago. Now that's awfully close to 180.
Yeah, it is.
Secondly, in my first fossil digs in Massachusetts, discovered a fish bed that was at the Triassic-Jurassic boundary. And what was usual about it is all the fish are highly radioactive. And when I analyzed those fishes in my chemical laboratory in my parents' basement, I came up with radioactive cesium.
Cesium. Well, that's a fission product. Cesium-132 is a well-known strontium-90, cesium-132 is the kind of the pair of. So,
what is that doing at the Triassic-Jurassic boundary? On top of that,
it suggests that the history of Earth is complicated.
Yes. And the dinosaurs took off after that.
Complexities.
Dinosaur tracks increased by at least 50% right after that boundary.
Well, the dinosaurs obviously benefited from this.
Yes. And so did the plants that fed them, which became the dominant type of vegetation on Earth. So.
Oh, yeah. Well, the biosphere recovered even from this. And,
I'm wondering if there could be anything connecting this extinction on Earth with the one on Mars.
Well, unfortunately, we're dealing with a lot of unknowns here. We have evidence for the civilization on Mars. It looks as though it was primitive, but we don't know its technological level. We certainly, if somebody came from outer space, from another star system, and decided to make an example out of Mars, kind of a pyramid of heads like the Mongols would do, it looks as though they decided to go hit Earth too then, even though there was no civilization there.
Could the blast on Mars have been so energetic that it hit Earth on one side? Because the opposite side.
Well, it's certainly possible, but it sounds to me as though they had a few bombs left over and they decided to just nuke Earth just to be on the safe side.
A recent development by palynologists in China showed that China at this Triassic-Jurassic boundary showed no significant extinctions at all on the opposite side of the Earth. But on the Atlantic side, you had all of these animals and plants being wiped out.
That's very strange. Yeah, well, we're, like I said, Kansas is stuck in the middle of Oz, actually. It's just, it's the island of the familiar in a sea of strangeness.
Yes, the Oz factor.
The Oz effect. So thank you very much for pointing that out. I was certainly not aware of that. Is anyone else noticed that and put it in the literature? By the way,
Oh, all of this is in the
I can
literature.
tell you that a lot of scientists, if they find something really weird, they just don't publish it.
Well, I published a paper on this radioactive fish layer at the Triassic-Jurassic boundary on ResearchGate. I'll send you a link to it, and you can.
Thank you very much.
Okay.
Yes, Bruce.
Yes. I'm still here. Are you still hearing me?
Yeah. I'm still hearing you.
Well, anyway, I'll send those.
The story of Earth is apparently much more complicated than anyone guessed. Numerous extinction level events. One of them may even be recorded in the Bible and a lot of other mythologies is the Great Flood.
Correct.
Apparently it was some catastrophic climate catastrophe, well, and you think what could cause that? Well, if somebody dropped, well, anyway, let's just put it this way. Once Earth is part of a living cosmos, even before that predates humanity, of course it predates humanity, then everything becomes really complicated. And, but we have to go out and engage the universe as it is. We can't wait for it to come to us, and we have to go out and meet it halfway.
I thank you very much for your talk today with your slides. It clarified a number of points that I had questions about concerning the isotope and the ages.
Yeah, well, in particular, I did a thorough search of the literature to see if anyone had any explanation for the xenon 129, which when I showed the Mars isotopes to nuclear weapons experts, none of whom can be quoted, they all agreed that this was signs of a nuclear attack. They didn't explain why. They just said, yes, it's obvious. But I guess since the mainstream science community has no explanation for why the xenon 129 would appear absent the xenon 132 from longer lived decay longer lived isotopes decaying, that convinced me that, okay, this is a real problem, a real anomaly, and we have to look for another explanation, which the nuclear explosion offered.
One other point that I would like to make, if I may, I worked with Richard Hoagland back in the early 90s and saw all
very good, very good.
So I am following up on.
Brilliant man. He made the face on Mars as familiar as George Washington on the dollar bill.
He sure did. And one of the things that I discovered is that it was through an image of the DNM pyramid that Michael Hanlon published for Mars in the real Mars. And when I looked at that picture, he was presenting it as proof that the DNM pyramid was a natural formation. And as a geologist, I looked at that and I just freaked out. That's probably why I'm going bald.
Find me someplace on Earth where you have a pyramid-shaped mountain like that.
Exactly. But I saw clear evidence of mass wasting, collapse, the underlying sediments being squeezed out from underneath the weight of the pyramid, and one of the ridges on it sliding down the side and creating an arc. deformation around the side of the pyramid. And
I'd like to see those pictures. If you have them, you could send them to me.
I have a web page out already on it, so I'll send you that.
Good.
One. And basically,
please post everything in the comments because I absolutely am loving all of this, guys. Amazing, amazing work.
Yeah, Bruce, if you could paste that in comments. Yeah.
My the stuff. Okay, here. Let me go. Find. Oh my God.
Yeah, and if it's okay, Bruce, I'd like to move on to Harold also because we're starting to push up against our time.
I'll just go to
right.
Check.
Okay,
right, thank you.
Bruce, thank you again, sir.
Thank you.
Okay, Harold, go for it, sir.
Wow, amazing presentation. Thank you.
Thank you very much.
To you, with all your research, I mean, obviously you have spent a lot of time studying Mars. My question for you is this. Is there any analogy? What benefit would be going to Mars? Like when Kennedy made a moonshot, we benefited with, all the great technology, everything that was developed. Now, if you had to give a speech on the great moonshot going to Mars, the same as Kennedy made a moonshot, what would it be like? What would be the justification? What would benefit would be going to Mars and establishing scholarship? What would it be like? Can you
I would
speech right now?
I would say that based on what has been found, what the evidence on Mars of this horrific tragedy, that we are going to Mars to investigate as thoroughly as possible using people, human beings, digging through the ruins in order to increase the probability of our own survival. Our survival as a species depends on us now understanding our place in the universe and improving it. Right now we are, a young, rather primitive species, and we have to get better. We have to become like the Federation in Star Trek.
Well,
that's my belief.
I agree with that. We need
that will increase the probability of our surviving.
That's a good argument, and I agree with that. But let's say that we decide NASA or whatever decide to go to Mars. What kind of benefit in terms of technology and knowledge to humanity would be taking that trip? What do you think would be like? Would it be something like in Star Trek?
It will lead to an explosion of all kinds of technology, from information technology to propulsion, power technologies. Everything will explode due to this, as it did when Columbus discovered the New World. It led to a revolution in Europe and in thinking about the universe. And the naval, the merchant marine targeting instead of the Mediterranean to target the Atlantic as a place to travel, and all of the thing, because the Atlantic is a much stormier ocean than the Mediterranean. It led to just an explosion of thinking and technologies in Europe when Columbus made his discoveries.
Oh, actually, now you've been good. I hope many are listening to you.
And this is empowered by the Queen of Spain, Her Majesty Isabella.
Okay, well, so let me do this. I'm going to go to Thomas Anderson really quick. We're going to try and squeeze through here. So Harold, thank you. Let me go to Thomas.
Hello.
You guys went too fast, man. I had just stepped out of the room.
Oh dear.
Yeah, so we're almost out of time. What was your question, Thomas?
Okay. Well, the first thing I wanted to comment on was the Federation thing. That's why I've been working on replicator technology, because I don't think if we move forward toward transportation technology and weapons technology, that we can move forward, you know, with fearlessness. Instead, we'll move forward in fear, with the most basic fear of, you know, going without. So instead of ending up with a federation, we end up with an empire. Top-down approach.
I'm half Viking, so fearlessness is a state of mind. It doesn't have necessarily anything to do with reality. It's a determination that you're going to go make your way.
Right. Well, like I said, though, if you have no fear of doing without, you have plenty of resources to work with, because there's always more to be gotten. And we begin, basically, we hoard the one thing that we can't make more of, which is room. Right. Get rid of all the clutter.
We have to learn from the mistakes of our own history.
Right. Oh, yeah. Right. Well, and not just our history, but the history of like all evolution. I mean, squirrels gather nuts, and they end up with nuts that rot because they're afraid of going without for the winter. And it's just an instinctual thing. So, you know, to break free of that.
Rotten nut is better than no nut at all, don't you think?
Right, right. And in that environment, that's, you know, that's what enabled all of the species to eventually culminate in what we are now, right? If you go by evolution. So develop the technology to manufacture and compact it so that you have it on your desktop. You want to try out a design for a warp drive? You can use that device to build a bigger device and then print those parts out and try it yourself, and not be limited with, oh, do I have the money? Do I have the manpower? Can I do this? Can I do that? You know, no, you just go ahead and try it. Open source everything. Now, this is just what I'm seeing for the future.
Oh, yeah, no, you're talking about creating an environment where innovation and experimentation will be encouraged rather than discouraged.
Right, and almost unlimited, because the technology I'm working on isn't just a replicator; it's a refining and energy harvesting technology.
Thomas, we're almost out of time.
Right.
So.
Well, let me get to the question. The stuff that you found there, could that stuff and those aspects of Mars not be caused just as easily by a massive amount of like mining, like strip mining and whatnot, and preparing to move because the planet is about to become uninhabitable, where they, you know, moved, say, from Mars to Earth and just stripped all that away.
There's no evidence that the hot spots of thorium and potassium I mean, they were under a kilometer of water when apparently this thing happened.
So the amount of time
no evidence for any mining there or anything. It's smooth.
Right. Okay. Well, I'm just looking at the size of the planet and the massive amount of oxidation, but yet there's almost no oxygen. It's almost all carbon dioxide that's left behind.
Well, Mars is red because it's highly oxidized. You look at pictures of Earth, of the Sahara Desert, it's red too, for the same reason.
Right. Right.
Okay.
Yeah, that's why oxygen's the second or third most abundant element.
Sagan pointed out that meant Mars used to have photosynthesis, and then quietly backed off that opinion.
Well, yeah, we found oxygen on signatures on other planets, and they realized, wait a minute, carbon dioxide can be broken apart by UV rays from, you know, the stellar body too. So you can't really count on plant life being, or what we consider plant life here, to be the contributor. There might be something else.
Well, what you get is carbon monoxide then.
Okay.
Right.
Well, yeah. So
anyway, yes.
Yeah. I should apologize for having to cut it short. We're at the top of the hour, and actually we have another presenter. So what I want to do is I'm going to mute everybody out here. So again, I want to put this thing back on gallery view, and everyone, please give Dr. John Brandenburg another applause, an enormous applause. Sir, thank you so much. Thank you so much. Okay. So what I want to do now is our next presenter. This is a little bit different for us, and that's why I'm so excited. But let me do an intro first here. Okay, and I'm going to put this back on speaker view.